Okay, children, let us continue the same thing, that is the pressure. In this session, we are going to discuss about the numerical part, how we can calculate the pressure developed by anything, any object. As we know the formula, that is pressure is equal to force upon area. Here the force is also equal to weight of object. So that we can write it is also equal to weight upon area. It is area. Here we can calculate. We are going to calculate the pressure developed by any object. Suppose we take the cuboidal object. It is a cuboidal object. And this cuboidal object has length, breadth and the height. Three measurements. Suppose we take the length of this cuboidal object is 50 centimeter. 50 centimeter. Breadth is it is 30 centimeter and height is it is 10 centimeter. These are the three measurements. Now the weight of this cuboidal object, it is given, that is 500 Newton. The weight is given. It is given all the measurements. The weight, length, breadth and the height. Three measurements are given. Now if we put this cuboidal object on any table, horizontal table, definitely this object will apply force on it because of its weight. Due to that force, the pressure is developed. The pressure will be experienced by the cuboidal object and also pressure is experienced by earth. We are going to calculate the pressure. But the thing is, in which orientation this object is placed. Since it is cuboidal object, it can be placed in different manner. If I take the example that this is the book Q in the cuboidal shape and it has the length, breadth and height, three measurements. Its weight is given. This book can be placed in three different orientation. If I put like this, here you see on the surface which dimensions are in contact, the length and the breadth. Here this 500 Newton object applies force from this surface area, that is length and breadth. If this object is placed like this, in this way, here you see, in this case, the surface is in contact with the ground or floor is length and height. Length and height are in contact with the surface. If it is placed in this orientation, now you see the breadth and height are taken for the calculation of area. So if we change the orientation, then the surface area of this object in contact with the ground is changing. When the surface area changes, the pressure developed also changes. That's why if the same object is placed on the same surface in three different orientation, then the pressure developed also changes. Different. Now if we take the first case, in this case length and breadth are placed on the surface. Then pressure is equal to force that is equal to weight 500 Newton upon length into breadth. Length is equal to 50 centimeter. 500 Newton upon 50 centimeter into breadth, it is 30 centimeter. Now if we calculate this, 500 Newton upon, it is 1500 centimeter square. One thing you must know, while we calculate anything, the units must be in proper order, either in SI unit or it should be in the same unit. Here you see this is in the SI unit, but here it is not in the SI unit. SI unit of area is meter square. It should be changed into meter square. To change the centimeter square into meter square, just divide by 10,000. So, if we write 500 Newton upon 1500, and if we write the 10,000 on this denominator, it goes to numerator. So, 10,000. And it comes meter square. Now, if we calculate, if we cancel it, and it comes 3. Now it is 10,000 upon 3 Newton per meter square, or you can write it is 10,000 upon 3 Pascal. This is the pressure exerted by this cuboidal object when the length and breadth are in contact with the surface. Then coming for the second case. For the second case is, we are going to take the force upon this breadth and height. Now in this case 500 Newton, and here the area, breadth and height 30 and 10 centimeter square. Now it is 500 upon 300 meter square into 10,000 if we calculate this. Now it comes 50,000 upon 3 Pascal. Here you see, it is 10,000 upon 3, it is 50,000 upon 3. So pressure same? No. It is changing. That means changing the area, the pressure also changes. If we go to the third case, in that 500 upon, now come to this is length and breadth. Here it is breadth and height. Now length and height. In this case 500 upon length and height, this is 10 and 50. That is 500 centimeter square, and it is changed into meter square, 10,000. Now you see this is 10,000 meters Newton per meter square, that is equal to Pascal. You see, in all the three cases the pressure is different, and you can find the value which is greater when the area is small. Which area is smaller? Here the area is 1500 centimeter square. Here the area is 300 centimeter square. Area is 500 centimeter square. And you can compare the values of all these pressure. This is 10,000 upon 3, 50,000 upon 3 and 10,000. You find definitely this value is greater. So for the smaller area, the pressure is more. And this is how we can calculate the pressure exerted by anything. And this can be used for any other example also. We'll see in the next video.